this is to show to you the EOM for problem 5.63. So as you can see, you have this two-story building frame. So maybe it's a bit confusing. Maybe if you want to draw the model, you can actually draw the model as shown here. But to clear up some confusions, you can also draw it as such, because all your masses are actually a point mass, okay? But for purposes of free body diagram, we draw it like a square. So it doesn't matter if you draw it like this, or you can also draw it as shown here. So once that's the assumption that we do basically when we actually look at real problems. You have to decide what is the assumed model. So in our case, of course, we are assuming that this is a 2 degree of freedom system with base motion. So this is the common model that we use. So you need to make a bit of assumption when you actually solve any problem. All right. To actually derive this, basically you are using the same method. So I've drawn here the assumption. So remember, the first step is when you have 2 degree of freedom system, you have to actually assume the or determine the relative displacement. Any elements in between two position, okay, like in this case your K1 as well as your K2. So you have to make an assumption, because K2 is in between X1 and X2, K1 is between Y and X. So in this case, it's up to you whether you want to assume tension or compression, or a mix of two. In this case, I assume it's in tension. So you just need to follow the action reactions and draw the free body diagram as I showed to you. After that, you have to write the relative displacement after you assume that it's in tension or compression. So in my case, I assume tension for K1 and also tension for K2. Okay, then you write your relative displacement. So how do you do it? Basically, you look at the arrowhead here. Okay, this arrowhead, same direction. This arrowhead here is owned by X1, so same direction, so it's positive. And this one is opposite direction, so it is negative. So I want to write here, this side here is a negative Y, this side here is positive X1. Same here, this side here is negative X1 because it's opposite, the arrowhead is opposite than X1. And this the right hand side of K2 is positive X2. So the way you write your relative displacement here is X1 minus Y. This one is X2 minus X1. Okay, so now you have all the free body diagram cleared. Then you can write your EOM. So for the EOM, you have to only write for your M1. Okay, so for your M1 and also M2. Okay, so for the first one, based on your M1, you only have 3 forces there, including your F1. So the way you write it, you write M1 X double dot 1, okay, because your mass only moves at X1, X double dot 1 is equal to summation of forces. So in this case, we always assume all with the same direction to the right is positive. Your assumed direction is positive to the right. Okay, the way you write your forces, you have this force, which is negative. Okay, negative K1 X1 minus Y, and this one here is positive. So positive owns by K2, yeah. So positive K2, x2 minus x1, and then don't forget you also have the F1. So plus F1. Okay, then you can rearrange the equation of motion. So I've done the equation of motion. You have to rearrange according to your x1 as well as collecting the terms of x1, x2 and y, and then you leave your f1 on the right hand side of the equation. So we've done with that. So now take a look at the second EOM. So the second EOM involves only this. So you only have you have F2 and K2 x2 minus S1. So you only have two forces. So let us write for the second mass, M2 x double dot 2 summation of forces. So same, going to the right is positive, same direction of all the forces. So you have your K2. So K2 is this direction, which is negative. So you have K2 is negative x2 minus x1, and then your F2 is positive. Okay, then you just rearrange. You have M2 x double dot 2, and then you put your plus K2 x2, and you have your plus become negative K2 x1. Okay, you leave the F2 at the other side of the equation. Okay, so if you want to put it in matrix, so you can do so. So just looking at the first equation, okay, so you are putting it here, and the first row you have m1 x double dot 1, so there's no m2, so that's why it's 0, and then you have k1 plus k2, which actually for x1, and then your negative k2 for x2. Okay, so just now I forgot, your k1y is basically input to the system, so you can bring it to the other side. So I put as f1 plus k1y. So then the second equation, you have m2 x double dot 2, so there is no x1 is 0, so you have m2 x double dot 2, and then you have k2 x2. So your k2 x2 here, because that is the location for your x2. For your x1 you have negative k2, so you put it here, so then you have f2. So okay, that's all for the free body diagram, and also how you get the EOM for problem 5.63. Okay, so thank you very much.